Hi guys, this is Miss Scott. So I guess we had a little issue with the audio in the previous 6.4 notes video, so here's a new one for you. If you didn't have any issues in the first place, just ignore that. Here's your bad joke of the day. Why is it so easy to get into pirate college? Because all you need is the high C's. Alright, so not too bad. You don't need any A's or B's, just the high C's. Okay, so today we're going to show how to prove triangles are similar. First by what we call the angle-angle similarity postulate. So if you would like to pause the video and go ahead and jot down your essential question, and then we'll talk about that angle-angle similarity postulate. All right, so what we have here is that if you have two angles in one triangle are congruent to two angles in a second triangle, then the two triangles are similar. So let's look at a picture of that. Say I have this triangle here, and I have this smaller triangle here. If I know this angle and this angle are congruent, and then these angles here are congruent, and suppose this is triangle ABC and triangle DEF. Well, if you have that situation going on, then you can say triangle ABC is similar to triangle DEF. And then once you know they're similar, you can set up proportions to find missing side lengths. Alright, so let's look at example 1. We're going to determine whether or not the triangles are similar by angle-angle similarity and the reasoning. If similar, give a similarity statement. Alright, let's look at extending these two lines here. So I know that line SR is parallel to line TU because it has those arrows there. So if I extend those and then consider this line SU as a transversal, alright, and we'll move that down a little bit here. What we can show there is that we have these angles here, so the angle S here and U here. If you remember from previous chapters, those are alternate interior angles. And we know since these two lines are parallel, since we have these arrows on these two lines, those angles are congruent. Alright, we also know that these angles in the middle, where we have point V here, are what we call vertical angles, and those are also congruent. Alright, so that's actually enough information to prove that two angles are congruent, so these triangles are similar. So we would just say yes. Our reasoning is just right here, that the fact that these are alternate interior angles and then these here are vertical angles, so we can use that as our reasoning. And then it says, if similar, give a similarity statement. So a similarity statement is just stating two figures are similar. So I'm going to put triangle V goes with V, S goes with U, and that means R has to go with T. So that would be our similarity statement. Triangle VSR is similar to triangle VUT. Okay, let's look at another example. So first of all, we're looking at this little triangle EAB and then that bigger outer triangle DAC. So notice that they share angle A. So we can say that angle A is congruent to angle A. And if you remember, that was that reflexive property that we learned earlier this year. Alright, and then we know that these angles B and C are congruent to each other because they're both 52 degrees. So angle C is congruent to angle B. Alright, they're both 52. So notice we have two angles that are congruent. So again, we can say yes by that angle-angle similarity postulate. Triangle A goes with A, B goes with C, and that means E has to go with D. So those would be the similar triangles. Okay, now let's throw in some numbers so we can solve for missing sides. All right. So first of all, let's just look here and figure out if these two triangles are similar. Well, we have that angle M is congruent to angle G, and O is congruent to H. So yes, these are congruent. So triangle MON is congruent to triangle GHI by angle similarity. Okay, now the scale factor, we just have to pick two sides that match up and then simplify. So remember, K is the letter we use to represent that. I notice that this side of 16 matches with 12, so I can set that up. These are both divisible by 4, so my scale factor is 4/3. All right, let's set up a proportion to find the value of x. I'm going to start with that same fraction from earlier because I know 16 goes with 12. I'm trying to find x here, which goes with 10, so I can set up x over 10, and then this proportion is something we can cross multiply. So we get 12x equals 16 times 10 is 160, and if we divide by 12, we end up with x is 13.75. Okay, now to find the perimeter, what we can do is actually the perimeters are also proportional because perimeter is just a length. So notice we can find the perimeter of the small triangle, GHI, because we know all three sides. So if we add all three sides together, we get 30. And then let's say the perimeter of MON, let's just call that P, so we can solve for P. All right, so if we have the small triangle over the big triangle, and then again we can set up using two sides, again 12 is in the small triangle, goes with 16 in the big triangle. So we're doing perimeter over perimeter equals side over side. And if we cross multiply, we get 12p. Over here, 30 times 16 gives us 480. And if we divide both sides by 12, we end up with the perimeter is 40. And that makes sense because notice if we would put this perimeter of 40 over 30, that would end up equaling our scale factor here. All right, so that makes sense. Okay, so to finish up the lesson here, we are going to look at a couple of story problems. So it says that Russell is 5 feet 9 inches tall, notices his shadow is 9 feet long, and they give us that in paces, while a nearby light pole has a shadow of about 17 paces. How tall is the light pole? Well, first let's just put everything into feet so that this makes a little more sense. 9 inches is 9/12 of a foot, and 9/12 is 3/4. So this is the same as 5.75 feet. All right, and then 17 paces, well, they tell us that 3 paces is 9 feet. So if we multiply this by 3, that means 17 paces is the same as 51 feet. Okay. Now let's draw a picture to kind of represent what's going on here. So here's Russell, all right, and here is his shadow. All right, so his shadow is here. All right, and then we have this light pole over here. Boop, 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 boop. It helps if you add sound effects. All right, and then it has a shadow over here. Woo. All right, it's a beautiful light pole, if I do say so myself. And we have some measurements we can put on here. So we know Russell's height is 5.75 feet, and his shadow is 9 feet. And then we know the shadow of the light pole is 51 feet. And we don't know how long that or how tall that light pole is. So let's go ahead and call that x. So if we've got this going on, we can set up a proportion here. I notice that this 5.75 here goes with x, so I'm going to put those together, 5.75 over x. And then this 9 feet goes with this 51 feet, so we can set that equal to 9 over 51. And then if we cross multiply, we end up with 9x. And then 51 times 5.75 is 293.25. All right, and then if we divide both sides by 9, we end up with x being about 32.583 repeating. And it turns out that 5.83 repeating, so just off to the side here, 5.83333, if you plug 7 divided by 12 in your calculator, that's what that decimal is equal to. So this is actually 32 feet, and 7/12 means that that's 7 inches. So that is the height of that light pole. All right. Kind of interesting that it turned out to be a nice number of inches. That was kind of cool. Okay, one last example here. So we have an A-frame. This should not say A-Grace. This should say an A-frame house. So let's move this down. Sometimes autocorrect gets the best of us. All right, so the A-frame house in the figure has a balcony that is 16 feet long, 16 feet high, and parallel to the ground. If the building is 28 feet wide at its base, how tall is the house? All right, so we're trying to figure out how tall this whole house is. We know from the ground to the balcony is 16 feet, so we need to know what this additional height here is to get from here up to the peak. So let's just call that x right there. All right. So if we look, I'm going to consider two things. I'm going to look at this little triangle here, and I'm going to make a ratio of its base to its height. So that little triangle on the top has a base of 16 and a height of x. Let me grab another color here, because now we're going to look at this entire outer triangle, and we're going to make a ratio of its base to height. So its base is 28. Its height is this entire thing here. So it's not just 16, but it's 16 and this length of x here. So the height of that big triangle is actually 16 plus x. Then we can go ahead and set those equal to each other because these are similar triangles. So again, we can cross multiply to solve this. So we get 28x. And when you cross multiply over here, you have to take 16 times that entire thing, 16 plus x. So notice we're going to do some distributing here. We end up with 28x equals 16 times 16 is 256 plus 16x. And then let's go ahead and get those x's all to one side. So we end up with 12x equals 256. So if we divide by 12, turns out that 256 divided by 12 is 21.3333 feet. And if you think about it, 0.33333 is a third, and a third of a foot is a third of 12 inches would be 4 inches. So this actually equals 21 feet and 4 inches would be the height of that entire house. Or actually, it wouldn't be the height of the entire house. This is just x. So this is 21.3 repeating. So to find the height of the whole house, we have to add on that 16 feet from earlier. So we have the height, our final answer, is 16 plus the 21 feet 4 inches. So our entire height, 16 plus 21 would give us 37, not 36. So we end up with 37 feet and 4 inches. All right, so we still have to add on that 16 feet from earlier. All right, guys, thank you for watching. If you have any questions, come find me. I will help you out. Feel free to subscribe to my channel, leave any comments or questions down below, and I'll get back to you. All right, see you guys next time. Take care.